Losses follow exponential distribution with mean 1. Two independent losses are observed. Calculate probability either of these losses is more than twice the other. So if we call the two losses as x and y, then we have to find the probability y is greater than twice of x or x is greater than twice of y. And both of these will be identical because of symmetry. And therefore, we can just calculate one of them. The other one would be the same, and or means addition. So we just calculate one of them and add it to the same thing or multiply it by 2. So probability y greater than 2x is conveniently calculated through the complement. It's equal to 1 minus probability y less than 2x. Now, strictly speaking, this should be y less than or equal to 2x, but we know that whether we have the equality here or not doesn't matter in case of continuous variables. And both of them, both x and y, are exponential with mean 1, so their PDFs will be 1 over 1 e to the minus x over 1, so that ends up being e to the negative x with the x and e to the negative y with the y, and this one has x greater than 0, this one has y greater than 0, and x and y are independent, and therefore the joint PDF will be the product of the individual PDF. So they're independent, and the region is a rectangle. It's actually an infinite rectangle, x greater than 0, y greater than 0. So the region is actually the whole first quadrant. And so the conditions of independence imply that the joint PDF would be e to the negative x times e to the negative y. And probability y less than 2x, if we look at the region, so we'll have to integrate the joint PDF. And if we do it first with respect to y, we take a vertical strip. So y is equal to 0 on this one because this is the x-axis, and the upper end is y is equal to 2x. So therefore, y goes from 0 to 2x, and x goes from 0 all the way up to infinity because there is no bound, no upper bound for x. And so e to the negative x is a constant for the inside integral because that's with respect to y, and the integral of e to the negative y would be e to the negative y divided by -1. So that's negative e negative y by our shortcut. Remember, integral of e to the ay would be e to the ay divided by a, and a in this case is -1. So dividing by -1 is same as multiplying by -1. And so you put in the upper limit is y is equal to 2x, so it'd be negative e to the negative 2x, and then minus the lower limit, so minus negative e to the 0, so that'd be plus e to the 0, which is 1. And then we distribute the e to the negative x over this, so e to the negative x times e to the negative x is e to the negative 3x. And e to the negative x times 1 is just e to the negative x, and then the integral of e to the negative 3x is e to the negative 3x over negative 3, and we already have a negative here, so it'd be just e to the negative 3x over 3, and this would be e to the negative x over -1, so you get negative e negative x, and the upper limit is infinity, and when you do e to the negative infinity, this is 0, so this one is 0 and this one is 0 when we put the upper limit, so we put the lower limit minus the lower limit, and e to the 0 is 1, so minus 1/3 minus 1. And so this simplifies to 2/3 because these are both zeros. And so we got probability y less than 2x is 2/3. So y greater than 2x would be 1 minus 2/3, that's 1/3. And that would be the same as probability x greater than 2y because the whole situation is completely symmetric. PDFs are symmetric in x and y, and so is the region. So each of these, y greater than 2x or x greater than 2y, each of these is 1/3, and we want the probability that or that, so you add the two, so 1/3 plus 1/3, that is 2/3, and that is choice E.